So in this section, I'm going to talk to you about this important idea of perpetuities. Let me try and explain that using an example. So let's suppose that you have a benevolent and a rich uncle, and he promises to give you $500 every year, and he says that he's going to do this forever. This is the key, forever. Now you might say, well, nobody lives forever. You're probably right. But let's do away with that technicality for the time being. So let's suppose that you will get your $500 every year, one way or another. It's definite, it's certain. And your uncle further says that, look, I'm going to give you the first $500 1 year from now. Now, if you were so inclined as to represent the stream of cash flows on a timeline where 0 represents today, this is 1 year from now, 2 years from now, 3 years from now, then your uncle is basically saying, look, I'm going to give you the first 500 here, I'm going to give you the first 500 here, and I'm going to give you the second 500 here, third 500 here, and then this will continue forever. And if now somebody comes to you and says, well, how much is this cash flow stream worth to you today? What is the present value of that? Well, how would you approach this? You might say, well, this is straightforward because I know the general approach. The general approach is this, that I take the first cash flow, right? So I take the first cash flow and I discount it back 1 year. And I take the second cash flow and I discount it back 2 years. And I take the third cash flow and I discount it back 3 years. So generally, I'd say present value of this cash flow stream is going to be 500. And I'm going to divide it by 1.04. Right? So discount back. This is the first 500. Then I'm going to do the next 500. So 500 divided by 1.04 squared. So I'm discounting the second 2 years back. Let's take the third one, divided by 1.04 cube. And you can see where this is going. Because your uncle has promised these 500s forever, well, all you have to do is just sit down, relax, and keep on doing this forever. So do this for a time period 4, 5, 6, 7, 8, 9, all the way out till infinity. You have time for that, right? Nobody does. Well, so what do? Well, what makes this cash flow stream a little bit more convenient is because the numerator, 500, this is a common sort of a factor. So if I factor that 500 out, I can basically write this whole thing as 1 divided by 1.04, right? So 500 into 1 over 1.04 is going to give me this first term, and then the next term inside the brackets is going to be 1 over 1.04 squared, and this will continue to happen forever, right? So this entire, so this is going, these dotted lines represent that this is happening forever, right? And so what is nice about this expression, and this notice that this expression is continually, the next term in this expression is continually declining. Specifically, what is happening is that if you look at the second term here, it has a higher denominator, and therefore the value of this number is lower than this. The next term is going to be 1 over 1.04 cubed, then raised to the power 4 or 5. So subsequent terms will continually be declining. In fact, as this guy is going to become higher and higher, or as this guy is going to approach infinity, you're going to have something in the denominator which is going to be so large that 1 over that is practically going to be equal to 0. And which is why this whole sum of these terms, this will converge to a single number, because beyond that point everything is like an added 0. And it turns out that if you do the math behind all of that, it turns out all of this solves out to 500, and the entire sum in the bracket just solves out to 1 over r. Can you believe that? It's just as simple as that. And so this would be, and here R is going to be 0.04. R is the interest rate. And so this entire thing is going to solve out to 500 divided by 0.04, which is 12,500. Basically, when somebody asks you how much is this stream of 500 worth to you today, you're like, well, you can either give me $500 every year forever, or if you give me 12,500 today, I'm equally well off. You're like, really? You mean to tell me that if I am promising you $500 every year forever, that is only worth 12,500 to you today? I mean, look, dude, this is forever. You're like, you know what? Yeah, it is worth only $12,500 forever for today. You know why? Because if you gave me 12,500 today, so let's suppose you gave that to me today, you know what I'm going to do? I'm going to put this in the bank, and at the end of the first year, I'm going to get an interest rate of 4% on that 12,500. You know how much that is? That is exactly equal to 500. So after 1 year, after I've earned the $500 in interest, I'm going to go and pull that 500 out, and I'm going to get that 500 1 year from now. I'll still have in the bank 12,500. Right? I just drew out the 500 in interest that I earned. So by the end of this year, I'd still have 12,500, and then I'll let that grow another year, earn another 500 in interest. I'll take that out. And so by just putting this $12,500 in the bank, I can earn 4% on that and draw $500 from my account every year forever after that myself. And so yeah. 500 forever is literally worth just 12,500 to me today. And so that's how that works. We call this a perpetuity because the cash flow streams are perpetual. And technically speaking, the term perpetuity is reserved for not only those situations where the cash flow streams are perpetual, it's also reserved for situations where the cash flow that you're getting every year is constant. It's the same 500. So what makes a perpetuity is that A, it lasts forever, it's perpetual, and B, that the cash flows that you are getting at each point in time are the same number, right? So two things. So here's the general formula. If you are interested in calculating the present value of a constant dollar amount C, where in our example this was 500, C was some constant. So here I'm not differentiating between C1, which is cash flow at time period 1, or C2 or C3. So C1 is cash flow time period 1, C2 is cash flow time period 2, C3 is cash flow time period 3. In a perpetuity, all of these are basically the same number C, so that's why it's a constant. And if you're going to be receiving that every year in perpetuity, well, turns out that the present value of that is just C over R. Where please bear in mind two important things. One, R is your opportunity cost, or the annual interest rate. And this C, the first C that you're getting, is 1 year from now. This is critical. It has to be the case that the first cash flow is occurring 1 year from now. This formula is only going to apply. It's only going to apply if the first cash flow that you're getting is 1 year from today. And so this is what is referred to as a perpetuity. Sometimes you will also hear that this is referred to as an ordinary perpetuity. There's nothing ordinary about it per se. When we say it's an ordinary perpetuity, we basically mean that the first cash flow is occurring 1 year from today. So what makes an ordinary perpetuity if the first cash flow is occurring 1 year from today. we'll differentiate it from some of other related situations later on.